ohms. Using the graph, okay, the V here is, what is this? An estimation is a half of the box, 0.75, current is 0.5, okay. Now, both the wires are made of the same material, same length. Which wire is thinner? Okay, which wire is thinner? Same material, same length. Now, you know that the explanation is, what do you think? Thinner when the wire, remember the water? When the water tube is small, harder to move, harder to water flow in, the resistance is higher. So we choose the one that is a higher resistance, which is A. Okay, wire A is thinner. Why? As it has higher resistance. Okay? Right, that's the answer, all using R equals to Rho length over area. When the area is smaller, the resistance is greater. Okay, when wire A and B are connected to 1.5, calculate the current. So how to do this? Now when it's connected in the series, the total resistance will become 5 plus 1.5 equals to 6.5. Then you use V equals to IR. Your V is 1.5, I, your R. So for your I will be 1.5 divided by 6.5, 0.231 ampere. And that's my answer. 3 significant figure. Okay. Now please take note, in the O-level section C, usually they ask you choose 2 questions out of 3. But since this is a mid-year exam, that's why they are required, the students, to do all questions. But again, O-level is always choose 2 out of 3. Choose the best, most confident 2 questions to do. Okay, now look at this. A student investigates the refraction of light, shows the arrangement of the apparatus. The student uses a ray box, boundary between glass and air. Student measures G, the angle. She then changes the direction of the light ray and measures the new G. And this is the results. Okay, now you're supposed to explain why the direction changes as it passes through the glass into air. Now I'd like you to use a new piece of paper to write down your answer, and then stapler your questions paper together when you submit, because the space here is limited. Alright, now what happens when there is a band? 2 marks questions, so you have to answer. First of all, I know it's due to refraction. That will only give you 1 mark, but the thing is why it refracts. Because as light travels from glass into air, speed of light increases. Why increases? Due to the difference in optical density. So that will give you 1 mark. Right, then the second one would be, thus light will be refracted and bend away from Now it's bent away, okay, from normal. Because the speed of light increases, it wants to move away from the normal. That will give you 1 more mark. Okay? Next, part B. Use the data to calculate the missing value. So the missing value of A in the air. Now how to find the missing value of the A in the air? We need to find the refractive index because we don't know what's the refractive index. So first of all, I use sine I over sine R to find the refractive index of glass. So it will be sine 22.6 divided by sine. Oh yes, but remember there's a reverse. Okay, because this one should be the other way. Remember I asked you to write in the notebook. We cannot use this. It should be sine I over sine R inverse n, because now we are talking about from the glass, a denser, to an air which are less dense. Unless you are saying you are from glass to air, then you can use this formula. But for this, we're going to use this formula instead. So therefore, the answer should be sine I for your sine 40 over sine 22.6 equals to 1 over n. You cross multiply will be sine 40 equals to n equals to sine 22.6. n will be equals to sine n equals to sine I over sine R. Sorry, my mistake. I redo. Now, back to here. Come here. According to this, is 22.6. Here is 40. Alright. Let me write here again, part B. Same. Because you are going from glass to air. We cannot use this. Because it's from glass to air. From glass to air to the less than, we use this. Yep. I is 22.6. R is 40. N cross multiply. N will be equals to sine 40. Sine 22.6. Answer will be 1.67. Alright, now using this, come back to here. Okay, reapply. (1.67) is equals to sine. What you need to come here is 30 over sine your this angle, your air. So sine R equals to cross multiply sine 30 over 167. A would be the inverse sine of this. Answer will be, okay, that's your final answer. Right, next question. So I write here 56.6. Describe how direction of light as the boundary changes increase the angle to 25 to 50. What do you think? Okay, now it will definitely hit, it's a 4 marks question. It will definitely hit beyond the critical angle. Okay, now the critical angle, if you calculate, I write the answer for C here. If you calculate critical angle, sine critical, alright, you will realize that the critical angle is 36.8. Okay, now anything within the range, when angle of incidence is from here 25 to 50, right? Let's start from 25 to just before it hits the critical angle. What will happen? The light's ray is refracted as it travels